During the combat engagement, the operation of the five-barreled Hotchkiss gun was characterized by the continuous noise of gunfire. The cluster of barrels spun, unleashing 47 mm shells at a rapid frequency. A Japanese torpedo boat, executing a calculated high-speed approach toward the Russian cruiser, received direct hits. Subsequent shells pierced the vessel's plating, causing it to take on water and list. The gun crew acted in drilled coordination. One man cranked the barrel mechanism, the second adjusted the aim, and the third maintained the ammunition supply. The rate of fire reached 35 rounds per minute, a figure that was higher than the standard naval artillery of the era. The torpedo boat, despite the crew's determined attempt to launch their weapons, sustained critical damage and subsequently sank. This multi-barreled weapon demonstrated significant utility in naval battles. The history of this system began in France in 1873, when the Hotchkiss Company unveiled a 37mm design based on the Gatling principle. The engineering solution relied on using 5 barrels instead of 1. The operating cycle was organized so that while one barrel fired, the others were going through the loading and extraction processes. The cluster was rotated by a manual crank, which allowed for a high density of fire. Leading naval powers evaluated the invention as the rise of fast torpedo boats demanded rapid-fire weapons to protect larger ships. Traditional artillery systems could not reload fast enough, allowing torpedo boats to get within striking range. The multi-barreled Hotchkiss system was designed to address this issue, but the first modification had certain technical limitations. The 37mm caliber used a shell weighing roughly 1 pound. With a muzzle velocity of 1,427 feet per second, the ammunition often lacked the kinetic energy to cause structural damage. It took a large number of hits to put a vessel out of action. The company's engineers initiated an upgrade of the gun, aiming to increase its ballistic power, which naturally involved making the design heavier and increasing the recoil forces. The result of these technical improvements was the introduction of a new 47mm model in 1879. The general layout remained unchanged: 5 barrels held together by discs, a rotating cluster, and a manual drive, but its destructive potential increased. To operate the heavier system, the crew was increased to 3 men. The first number was responsible for rotating the barrels, a task that required physical stamina and a steady rhythm. The second number aimed the weapon using a shoulder stock. The third number continuously replenished the ammunition magazine. The effectiveness of the fire depended directly on the crew's synchronization, as any operational error could lead to the gun jamming during the engagement. Field tests of the artillery system demonstrated compliant tactical and technical characteristics. The 47mm rounds effectively pierced the hulls of light vessels, damaging superstructures and disabling weaponry. A firing range of 4,800 yards allowed the crew to engage targets before they could reach effective torpedo range. With a trained crew, the system's rate of fire reached 35 rounds per minute. This figure exceeded the fire density of standard naval artillery of the time. Information regarding the new weapon soon spread through European military circles, and foreign specialists traveled to France to inspect the design. The Russian Empire also evaluated this type of armament. Officials in St. Petersburg were monitoring trends in naval technology, noting the necessity to counter developing threats. With torpedo boats becoming faster and more maneuverable, The fleet's capital ships required an effective means of defense. After analyzing reports on the capabilities of the Hotchkiss guns, the decision was made to acquire them. The Russian side placed an order for over 150 units of various calibers. The first models arrived in the early 1880s, after which the Baltic Fleet commenced mastering them. The guns were installed on ships of various classes, and crews began target practice and drills. Operating this multi-barrel system required a specific set of technical skills. The key aspect was maintaining a smooth and even rotation of the barrel block, since any variation in rhythm affected the rate of fire. Crew preparation involved extended drills aimed at standardizing every action. Particular attention was paid to the crewman operating the crank. He required precision and consistency, even in rough seas or combat conditions. Trials in the Gulf of Finland confirmed the system's operational parameters. They recorded notable fire density and accuracy against targets simulating small vessels. Based on these results, ship commanders submitted reviews recommending an increase in the number of these mounts on board. Later, it became apparent that the initial purchase was insufficient to fully re-equip the fleet. The ministry in charge faced a choice between continuing to import or organizing local production. Priority was given to developing the domestic industrial base. In 1886, the decision was made to localize production of the multi-barrel cannons at the facilities of the Tula Arms plant. The French developer handed over technical documentation and provided consulting support. Manufacturing the barrel blocks was entrusted to the Obuchov steel plant in St. Petersburg. This technological process demanded strict adherence to metal quality standards and precision machining, since every barrel in the block had to be identical and withstand prolonged use without performance degradation. Any deviation from the set parameters for bore diameter or wall thickness created a risk of the gun failing during operation. The specialists at the Obuchov plant completed the production task according to specifications. The characteristics of the locally produced steel matched the French counterparts, and in some metrics showed different properties. The output underwent rigorous technical control. Strength and rifling quality were checked, and non-compliant parts were sent back to the furnace. Final assembly took place at the Tula plant, along with the fabrication of mounts and aiming mechanisms. The production process was intensive and involved a substantial workforce of skilled machinists. Mechanism parts were made with required precision and fitted by hand. The first licensed Hotchkiss guns were completed months after work began. The quality of the manufactured guns corresponded to the original French models. Engineers implemented a number of design changes to the mount, which modified its stability and handling. Proving ground tests confirmed the unit's ability to withstand the same rate of fire as the originals. Production volumes gradually increased, reaching dozens of units every month. The fleet was receiving weaponry designed for defense against torpedo boats. Guns of this system were installed on cruisers, battleships, gunboats, and auxiliary vessels of that period. The mounts were placed in locations that ensured optimal angles for defense against approaching vessels. The guns were mounted along the sides, as well as on the bow and stern, to ensure a comprehensive field of fire. Large battleships could carry up to 10 of these mounts, extending the close-range defensive perimeter. In the ship's armament system, the function of the Hotchkiss guns was anti-mine defense. unlike the main and medium calibers designed for large surface targets and coastal objects. Tactics were practiced during drills. Crews trained to fire at moving targets, accounting for lead time and trajectory adjustments. Attention was also paid to countering night attacks, which torpedo boats often used to approach unobserved. Gunners were required to identify the target in low visibility and open fire before the enemy could get within torpedo range. To do this, ships used powerful searchlights to illuminate the water during an attack. The combined use of searchlights and Hotchkiss guns became a standard procedure for naval anti-mine tactics. This type of weaponry became widespread due to its performance characteristics. Compared to early automatic systems, the mechanics of these guns were considered reliable, simpler to maintain, and could be repaired by the crew. The personnel noted the maintainability of these artillery systems. Among ship crews, the five-barreled mounts were given various designations, reflecting their role in service. In the early 1890s, the Tula Arms Plant was operating at capacity, ensuring a supply of multi-barreled systems to replenish the fleet. However, technological changes were occurring in the artillery industry. The French firm Hotchkiss presented a single-barrel automatic cannon of a similar caliber. Unlike its multi-barreled counterparts, which required mechanical rotation of the barrel cluster and a three-man crew, the new model used recoil energy for automatic reloading. The gun could be operated by a single person while maintaining a high rate of fire. Its main advantages were compactness and reduced weight. Engineers from the Russian department conducted a technical analysis of the design. Test results showed that the single-barrel scheme offered operational advantages. It occupied less deck space, weighed less, and required less physical effort from the crew. Reducing the weight of the design allowed ships to carry more guns without increasing the displacement load. Furthermore, the introduction of automation eliminated the need for synchronized work by several crew members, meaning manual errors no longer critically affected the rate of fire. The relevant ministry began considering a transition to this new type of weaponry. In 1896, the Tula Arms Plant was ordered to stop producing multi-barrel systems and retool for the production of single-barrel automatic Hotchkiss cannons. This decision was driven by both technical and economic considerations. Manufacturing a five-barrel cluster for a single gun required more resources than producing five separate single-barrel mounts. The Obukhov plant also switched to manufacturing the new models. The period of multi-barreled revolving systems in the Navy was concluding, yet the units already produced remained in service. About 150 guns purchased in France, along with hundreds produced in Tula, continued to be operated. They remained part of the armament of active ships, fulfilling their role in anti-mine defense. Crews that had trained on these systems continued to use them. New ships were equipped with modern single-barrel mounts, while older vessels retained the five-barreled Hotchkiss guns. This inventory status persisted right up until the turn of the 20th century. Among the officers, there was an opinion that the complete abandonment of multi-barrel systems had been premature. Even though single-barrel guns were lighter and more compact, their automatic mechanisms proved susceptible to failure in naval conditions. The exposure to seawater, dampness, and corrosion affected the complex machinery. At the same time, the mechanically operated multi-barrel systems remained operational in various conditions. Five-barrel guns saw use during the Russo-Japanese War. With the start of the siege of Port Arthur in 1904, the squadron was blockaded in the harbor. Battleships and cruisers could not deploy because of the Japanese fleet controlling the outer roads. The ships were used as floating batteries, but their armament was utilized in other sectors as well. The Japanese Third Army, under General Nogi, was assaulting the fortress from land, and the defenders faced an artillery shortage. Command made the decision to dismantle some of the weaponry from the trapped vessels to reinforce the land defenses. Work to remove the cannons proceeded continuously. The Hotchkiss multi-barrel systems, due to their rate of fire, were transferred to shore and installed on the fortifications guarding the approaches to the city. The guns were operated by sailors familiar with their design, which allowed them to bolster the coastal defense. The attacking Japanese infantry, advancing in coordinated waves, encountered rifle fire and a barrage of 47mm shells. The Hotchkiss guns were positioned along the identified avenues of approach. Firing points were placed in concrete casemates, reinforced with sandbags, and covered with available materials. The first engagements demonstrated the utility of naval artillery in land warfare. Organized infantry formations were subjected to fire from the multi-barrel cannons. A rate of fire of 35 rounds per minute allowed a single gun to suppress enemy forces. The shell bursts inflicted casualties and disrupted the formation of the attacking ranks. Japanese troops suffered losses, but, demonstrating military resolve, continued to assault the fortifications. The intensity of operation was high. Barrels overheated from continuous firing, and crews used water to cool them down. Ammunition consumption was significant, requiring the delivery of new batches of shells. The artillerymen maintained operational tempo, particularly in repelling night assaults. The Japanese command attempted to use darkness and terrain masking to approach the fortifications undetected, but the defenders remained on watch. Searchlights, previously dismantled from the ships, illuminated the terrain in front of the positions, allowing them to visually track the movement of the attackers. Upon detecting targets, the Hotchkiss gun crews opened fire, accompanied by muzzle flashes and the sound of explosions. The multi-barrel gun systems function not only as an anti-torpedo caliber, but also as a means of engaging enemy manpower. The situation at Port Arthur in August 1904 was characterized by high tactical tension. Japanese troops were preparing for a new, large-scale assault, concentrating fresh divisions and heavy siege artillery near the fortress. According to intelligence reports, the enemy planned simultaneous strikes on several sectors of the defense to disperse the garrison's forces and break through to the city. The leader of the defense, General Stessel, issued an order to reinforce vulnerable positions with additional artillery. Several multi-barrel guns were moved to the northern fortifications, where the terrain favored the attackers. At dawn on August 20th, Japanese artillery began a massive bombardment of the Russian positions. Heavy shells inflicted significant damage on the earthworks. After an artillery preparation that lasted for hours and destroyed the forward trenches, the shelling stopped. Then the Japanese infantry began their advance. Soldiers moved in dense lines. Officers with swords and buglers coordinated the pace and direction of the attack. The artillery crews waited for the calculated moment to engage. Battery Commander Vasily Gromov, commanding a battery of 4 guns, observed the advancing units. They opened fire when the distance to the advancing troops closed to less than 0.6 miles, and the targets became clearly visible. On command, the 4 guns began firing in a synchronized manner. 20 barrels worked in a single rhythm, providing a high density of fire. The first volleys hit the center of the advancing formations. Shell bursts and ricochets off the rocky ground inflicted casualties on the groups of soldiers. The Japanese infantry slowed down, but continued the attack under the leadership of their officers. Gromov adjusted the aim, shifting fire to the attackers' flanks. The crews, manned by sailors with naval service experience, worked in a coordinated manner. The gun numbers kept the barrel clusters spinning, aimed at enemy concentrations, and fed a continuous stream of ammunition, maintaining the rate of fire. After half an hour of combat, offensive actions in this sector ceased. Having suffered losses, the enemy forces retreated in good order, leaving casualties on the battlefield. Soon, the Japanese command committed reserves, renewing attacks in other directions. The fortress defenders shifted forces between defense sectors to plug breakthroughs and repel assaults. Hotchkiss guns were redeployed to positions where the tactical threat was greatest. The artillerymen operated under strain, staying at their positions for extended periods. Due to intense use, the gun barrels overheated to high temperatures, so the crews used wet rags to protect their hands and continue firing. On September 3rd, Japanese troops launched a massive attack on the eastern fortifications. They managed to place heavy artillery in close proximity to the defenders' positions and destroy a number of fortifications. Assault groups rushed into the resulting breach, which was about 220 yards wide. Amid the shortage of reserves and a critical situation, 47mm Hotchkiss guns, dismantled from the battleship Poltava, were delivered to the breakthrough point. The guns were mounted on the ruins of the fort, with temporary breastworks built from the debris. The artillery crews took their positions under enemy fire. Despite casualties among the personnel, the firing continued. As the Japanese infantry entered the breach, fire was opened on them from a distance of about 110 yards, inflicting damage on the attackers. The shells caused damage to the troops, impacting their targets directly. Meeting resistance, the attackers slowed their advance, which allowed the arriving Russian reserves to launch a counterattack and restore the defensive line. The breakthrough was eliminated with the participation of the artillery. According to the gun commander, non-commissioned officer Peter Selezniev, the crew expended more than 1,000 shells during 3 hours of continuous firing. Subsequently, the nature of the combat changed. The Japanese side switched to a tactic of night attacks by small, specialized groups to penetrate the defense line. In response, the fortress defenders stepped up patrols and observation. The guns were kept in readiness, and the terrain was illuminated by searchlights. Whenever Japanese combat engineer squads tried to approach to cut wire obstacles, searchlight beams would sweep across them. Immediately, the multi-barreled guns would open fire, cutting off attempts to break through. By November, the fortress was running low on ammunition, forcing command to impose strict rationing. Battery commanders received orders to fire only at confirmed targets. The crews manning the Hotchkiss guns had to let the enemy get within close range before opening fire to ensure accuracy. This tactic demanded strict discipline and focus from the men, who had to watch the enemy advance while waiting for the command. The personnel carried out these instructions despite the risk. In December 1904, the situation for the defenders of Port Arthur deteriorated. The fortress was completely surrounded. Outside supplies were cut off, and ammunition stockpiles were depleted. After Japanese troops captured the commanding high hill, their artillery could direct fire right into the city and the harbor, causing destruction and sinking ships at their docks. The garrison was taking casualties, and medical facilities were overflowing. Food supplies were critically low. General Stessel called a war council to discuss the possibility of surrender. Despite the critical strategic situation, the naval gunners continued manning their weapons and repelling attacks. The condition of the weaponry was poor. The barrels were worn smooth, reducing accuracy, and the mechanisms and mountings were warped from constant use. The men repaired their equipment with available materials, using wire, rope, and wooden wedges to enable further operation. On December 20th, the Japanese command sent envoys to the fortress with a proposal for surrender. Negotiations lasted several days, and on January 2, 1905, the Act of Surrender for Port Arthur was signed. Under the terms of the surrender, all fortress weaponry was to be handed over to the Japanese. Garrison officers were allowed to keep their sidearms, provided they pledged not to take up arms against Japan until the war ended, while the enlisted men were sent into captivity. Before abandoning their positions, orders were issued to render the artillery useless. Execution of this order varied. Some crews were reluctant to destroy the guns they had operated throughout the siege, while others left them in place or attempted to mask and hide the weapons. Gunner Gromov ordered the breech blocks removed and buried separately to ensure the enemy couldn't immediately use the captured weapons. Several multi-barreled Hotchkiss units were thrown into the harbor waters. Upon occupying the fortress, Japanese troops, observing the codes of military conduct, found a significant amount of artillery on the fortifications, including the multi-barreled Hotchkiss guns. Some of the trophies were repaired by the Japanese army and used in subsequent battles in Manchuria. Others were sent to Tokyo for museum display, while some were scrapped for metal. This marked the end of the combat service of the 5-barreled Hotchkiss guns in the defense of Port Arthur. These guns had journeyed from French ships to the Russian fleet and finally to the land fortifications of a besieged fortress, demonstrating mechanical durability in field conditions. The repurposing of naval gunners for land defense and the use of French designs in ground operations became a notable chapter in the history of artillery and the tactics of trench warfare at the dawn of the 20th century.